Hello everyone. Today we will be talking about nonlinear data structures. Now, as we know that data structures are required to store data with certain programs or in a file system which an operating system use. So different type of data need different type of storage systems and storage structures. So fundamentally on the storage types, there are two forms of data structures. One is the linear form of data structure and another is non-linear data structure. Now, as we know the linear form of data structures, the data is stored in a sequential manner, connected to one another, and we can have a run through within a single run throughout the data, which is not the same with the non-linear data structures. So we will be talking about the non-linear data structures in detail, and let's start. So as we can see here that the data structure can be classified into linear data structures and non-linear data structures, and in linear data structures we see array, stack, queue and linked list, and in a non-linear data structure we see graphs and trees. Now we know with our study of phylogenetics that the trees are a special case of a graph. So we will be discussing about graph in little detail, and it will be introduction of how a graph is and how it is essential in handling the data within the program or in a file system. Now when we talk about the nonlinear data structure, the data structure where the items are not organized sequentially, as it's called, is a nonlinear data structure. The data elements of nonlinear data structure could not be connected to more than one element to reflect the spatial relationship among them. So all the data elements in nonlinear structure cannot be transferred in a single run, as we know, and the examples are tree and graphs. So what are trees and graphs? A graph is a collection of a finite number of vertices and edges. Vertices are sometimes called nodes, and edges represent the relationship among the vertices that stores data element. The tree is a collection of nodes where these nodes are arranged hierarchically and form a parent-child relationship. It's a specialized form of graph. Now when we talk about graphs and trees, we know that tree is a special case of a graph. So like a tree, graph also have nodes and they are connected by the edges. Now technically speaking, we know this thing that graph is a collection of finite number of vertices and edges that connect these vertices. So as we know, the graph is similar to a tree, so it also consists of nodes and edges. Node here represent the simple attributes that we have in the graphs, and these edges shows the connection. Now talking about a graph. So now as we are talking about graph has no set of rules like in tree that we should have n-1 nodes. Okay, so we have no set of rules for how a connection has to be made between the nodes or the vertices and how this can be interconnected. So graph is defined by an ordered pair, that is VE, where V is the vertices and E is an edge, where the VG, that is the G, is okay. With this, a graph is defined as an ordered pair of a set, where the VG represent the set of vertices and EG represent the edges that connect to each vertices. Now with graphs, we have no set of rules that define how a node or vertices is going to be connected with another vertices. There are edges which connect these with each other and shows a relationship. Now before proceeding further, I want to tell that one should have a brief knowledge about what a set theory is. With this context, I want to tell you that a graph is defined as an ordered pair of a set, that is VE, where the VG represents the set of vertices and EG represents the edges that connect these vertices. Now what is it saying in mathematical terms is that VG, that is in the set, a whole set of graph, the V represents the vertices, and in the whole set of graph E represents the edges. Now how we mathematically define is, we can say that V as a set is consisting of the subsets or the attributes V1, V2, V3, V4, V5, V6, V7, V8 in this graph, and the edges can be constituted of the subsets, that is V1, V2, V1, V4 and V1, V3 as shown in the graph and as it is on your screen. So these are all the things which are possible within this graph in the terms of vertices and edges. Now graph can be represented in two ways depending on their edges. Now edge can be undirected or it can be a directed edge. So if graph consists of the edges which are undirected, it is called undirected graph, and when the edges show some direction towards an attribute from one attribute to another, it is called directed graph. So let us now talk about edges. As we can see here, there are two types of edges, undirected and directed edge, and we can see here in the directed edge there is an arrow which is pointing towards V. So it is a directional towards to the final point it has to reach. Now one of the basic example for this we can talk about is social networking. As we can see in social networking, we get some suggestions about this can be a friend or you can know him, and how does this happen. So let us have an exemplary situation where we have a node or a person who knows particular persons. The software try to determine how these people are interconnected, and this works on the graph theory. The interconnection between people are found on the basis of their contact list and how much they stay in contact on a social networking sites, example Facebook or your Instagram, and this is how a connection is drawn between people. Another example for the graph theory in which we can use in our daily life, that how does a Google Map figure out which is going to be the best path from our location to the location we want to go. So to find the shortest path, they analyze a graph. The paths and the further detail can be discussed in the later sessions, but here is just an example. So here is how Google Maps find out which is going to be the shortest way as depicted. So graph in the summary is a non-linear data structure which is a collection of vertices, or can also be called as nodes, and the edges that connect these vertices. So what are the uses? Graphs are widely used in many situations where entities or things are related to each other. One of the basic example in bioinformatics is the string database. It used the graph theory for depicting the relation between proteins, so it helps us to understand protein-protein interaction better. Now we also have the use of graph theory in phylogenetics, where we build trees to understand the relation between the parent and the child, with parent-child relationship in the phylogenetics. Also in the sector of transportation or shipping, routing, or social networking, there are various examples that we can talk about. Thank you.